What about the store instruction? Can we use the same format for a store instruction? What is the difference? Like when I write store instruction would be something like this. Let's extend, offset, let's say again 52 and x11. What is the difference between store and load instruction? While looking at the format here. Come on.
The content from register into the memory.
So yeah. So we do the same thing with load word instruction. In load word, we copy the contents from memory to registers. In store word, what we do?
We
copy the contents from register
into the memory.
to the memory, right? So when we are copying the contents from register, okay? So what is this here? Is this the destination register? It's a source. And what is this? It's also a source register, which contains the base address. We are not writing anything into this, okay? So in store instructions, both registers are source registers, okay? In load word instruction, the x1 here in this example is a destination register. Destination means like you're copying the data and storing into x1, writing it into x1, okay? So we cannot use this format because in this format we have RD and RS1. So this is the format for store instruction, and what we can do here is we can actually use the RD field for splitting immediate data. So this is the main format for the instruction. We do not have RD in SW instruction, so we are not going to use this. We have RS1 and RS2. So we will keep these fields in the same place just to keep the format same, and it will help the hardware designer to fetch RS1 always at the same location. Similarly, RS2 from the same location. Okay. In SW instruction, we do not have RD. Okay, but we do have RS1 and RS2. So we are going to use this field. We are not going to use this. So how we can store 12-bit immediate field? By storing the first 5 bits into RD. So immediate 12-bit immediate field will be split into 5 bits first are stored in this place, and the remaining 7 bits are stored at the funct7 field. Okay. Any question here? I know it's a little complicated, but this is how it is being designed, just to make the hardware implementation as easy as possible. Okay. Because we cannot, if we do not make things a little bit complicated here, we might need to have more hardware components, and that will actually increase the amount of resources that is required to implement the processor. Okay, so here RS1 corresponds to the base address, RS2 contains the source operand register number, and the immediate offset is split into 2 fields, okay, which is the first 5 bits are stored here and the remaining 7 bits are stored here. So if we have instruction like this, so x2 corresponds to RS1, x1 corresponds to this, and this is the opcode for store instruction, and this immediate 32 bits field are split. The first 5 bits are placed here, the remaining 7 bits are placed here. Okay. So this is only the procedure if you are working as a computer scientist in any company which are developing a compiler or the assembler. This is your duty. This will be your duty to write a piece of code which splits this offset value and place the binary equivalent into this location. Okay, this will be your duty. And the guys who will be implementing hardware, they will be responsible to fetch the data from here and there specifically, and they will be able to identify based on the opcode what does these 5 bits and what does these 7 bits correspond to. Okay, they are responsible to concatenate these 5 bits and 7 bits together in the hardware to make a complete 12 bits immediate data. Okay? Yep.
Can you explain the symbol IMM11?
So this is the immediate field. I am using just a variable name IMM. So if this is the entire immediate field, so starting from 5 to 11 will be placed here, and 0 to 4 will be placed here. Bit number 0 to 4 and 5 to 11 will be placed there. Okay? Yep. Any question?